So after all of this theory of OSPF we've been talking about, let's finally get around to actually configuring this thing. So let's talk about implementing OSPF. So the initial configuration of OSPF is pretty simple. A few things I want to call to your attention right here. So you would start out by configuring at the global configuration level your command router OSPF and then a process ID. Now I want to make a distinct difference between a process ID and an autonomous system number. In EIGRP, at the global configuration level, come on, you typed router EIGRP, and then you had to put your autonomous system number right here. And whatever number you put there as your autonomous system number was very important because that number had to match on all of the routers. In EIGRP, when a router sends out an EIGRP hello packet, it includes the autonomous system number as part of that hello packet, and those things have to match. Well, in this particular case, a process ID is not sent in any OSPF packets. It's simply a locally significant value. That's it. Now you might be wondering, Keith, what do you mean a locally significant value? When I use that term locally significant, that means only this router, only this device needs to be aware of that number. It's not shared with any other device. So most of the time when people configure OSPF, they use process ID number 1. You can use whatever you want. I mean, theoretically, on router 1, you could use process 1. On router 2, you could use process 2. On router 99, you could use process 99. It doesn't really matter. It does not have to match. The main thing to remember is, unless you have a real good reason for doing so, you should only have one process of OSPF running in your router, and that's it. As an example, let me contrast that with EIGRP. Once again, with EIGRP, if I had a router right here, let's say this is router X, Y, and Z, and let's say that Y and Z were part of company, let's say YZ, and then all of a sudden we acquire a new company. So this is an acquisition. And maybe we were already doing EIGRP in company XYZ, or I should say YZ, and previously we were using autonomous system number 200. So all of the routers here were using 200. All of a sudden this new acquisition we have, well, they were also using EIGRP, but they were using autonomous system number 77. So for the time being, router Y actually has to have 2 instances of EIGRP. You have to type router EIGRP 200, and so that's how he can exchange routes with his own internal company. And then also in router Y, you'd have router EIGRP 77. Totally different process that he can run with router X. Now those 2 processes will not share routes. They will be separate in router Y. We would have to redistribute between the 2 processes till one process send his routes into the other, and the other process send his routes back. That's something we'd have to do manually in router Y. Otherwise, they will stay separate and unique as if they were 2 completely different routing protocols. So that's the only time when you would really need 2 instances of the same routing protocol running in one router. Well, that also holds true with OSPF. In OSPF, you should only have to have a single process running in your router. Only if you're in a situation like this would you possibly need more than one process. But at the CCNA level, just think to yourself, I'm only going to type router OSPF some number, and that's it. And I'm never going to do that command again. I'm never going to have to create another process. One process is enough. And then you use your network command. Now in EIGRP, you had the option of using a wildcard mask. In OSPF, it's not an option. In OSPF, you have to include a wildcard mask after your prefix. And then you also include the word area and then the area number. So as an example of that, you might type network, I'm just going to shorten it, 25.70.00, and then a wildcard mask that would be appropriate for that. And then I would tell my router, okay, any links that you have on yourself that begin with 25.70, those links are going to be part of area 1. So that's an example of how you type the network command. Now the router will come up with a router ID by itself, but as you saw in the last video where we talked about designated routers and backup designated routers, you might want to deterministically set the router ID so that you can influence which router will become the DR or the BDR. And remember, every segment that needs a DR is a unique segment. In other words, if I'm a router with 2 Ethernet segments, on this segment, there's going to be a DR. It might be me, might be somebody else. And on this segment right here, that's also Ethernet, there's going to be another DR. Might be me, might be somebody else. But every broadcast segment or non-broadcast multi-access segment needs a DR and a BDR. Along those same lines, you could also influence the IP OSPF priority on an interface. Remember, the default priority of OSPF on an interface is 1. The default is 1. If you set the priority to 0, that actually means this router can never become a DR on that interface. It is disqualified from becoming a DR. Now, like it says here, both the router ID and the priority, if you change them, you need to restart your OSPF process. It will not take those changes on the fly. And then here's some verification commands we can use to see what OSPF is doing. So let's actually do an example of this in the lab. So I'm going to be using this topology right here. And the routers that you see with the light blue circles, router 1, switch 1, router 2, switch 3, and router 4, they have already been pre-configured for OSPF. So they are already up and running. And I'm just going to configure OSPF from scratch on switch 2 and router 3. Now before I do that, for example, let's go to router 2 and issue some verification commands to see what he looks like already, router 2. Okay, so what command would I type to see if this router has become fully adjacent with any other OSPF neighbors, or if he's learned of any OSPF neighbors in any other transitory state? Hopefully you said show IP OSPF neighbor. And you can see he's got one neighbor, 1.2.1.1. That is switch 1. So remember, when switch 1 was coming up with his router ID, first thing he said was, do I have any loopbacks? Nope, no I don't. Okay, what interfaces do I have that are either up, 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 down, or down, down? These two right here. Of these two interfaces, which one has the highest IP address? That would be this, 121.11. So switch 1 said, I'm going to create my OSPF router ID of 1.2.1.11. And that's what we can see right here. What do you think the router ID is going to be of router 1? It should be his loopback, right? Because the very first thing that's looked at is a loopback. So let's go to router 1 and take a look, which is also going to answer the question of, when I'm on a local router, how can I tell what its router ID is? You can just do the command show IP OSPF. Show IP OSPF. And right at the top, it says, here is my router ID. In this case, just like we thought, it's the loopback interface. So show IP OSPF shows you a lot of good stuff, as you can see right here. And once again, we can use our favorite command, show IP protocols. And that will give us some information about OSPF. Shows you what your locally significant process ID is. I just used the number 1 on all of mine. It shows you what neighbors you have, the administrative distance of OSPF. Going back here once again, because router 1, switch 1, and router 2 have already been pre-configured, router 2 should have learned about this loopback network, 111.111.111, and he should have learned about 1110 as OSPF routes. So let's take a look in his OSPF routing table of router 2. Show IP route. And there we can see, there's that loopback network that was learned via OSPF. And here's that other network that was learned via OSPF. And notice when a route is prefaced with just the letter O, that means that it is an OSPF intra-area route. What does that mean? That means that this route actually lives in the same area where this local router is. In other words, router 2 says, okay, the 111, 111, 111, and the 111, they both reside in area 1. And I live in area 1. So that is an intra-area route. Now let's go ahead and configure switch 2 for OSPF. And if you haven't already taken a screenshot of this, I would recommend that you do so you can follow along. So in switch 2, what I'm going to do is I'm going to have 3 network statements. I'm going to configure OSPF, and I'm going to put the 222 network into area 1. I'm going to put the 232 network into area 0. And I'm going to put the 323 network also into area 0. So my configuration will consist of a total of 4 commands. Router OSPF 1, followed by 3 network statements. And that will be all I need for switch 2. Router OSPF, and you can see here my process ID, locally significant value. You've got quite a range of values you can choose from. Most people usually just start with 1. And I'm going to say network 2220 with the appropriate wildcard mask. And that's going to be in area 1. Network 2.3.2.0. That's going to be in area 0. So right there, the fact that I have put 1 link in area 1 and 1 or more links in area 0 means this router is now an area border router. And network 3.2.3.0 also in area 0. Now, how could I tell that this router, now remember, it's a switch, but it's a multi-layer switch. I've enabled it for routing, so I'm just calling it a router. How do I know this device is running OSPF? Well, once again, show IP protocols. And if OSPF shows up here, which it does, I know it's running OSPF. It also says right here, it is an area border router, so he knows that he's an area border router. And this shows me the various networks where I've activated OSPF with the network command. So now I'll go ahead and put my light blue circle on switch 2, since I've just finished OSPF for him. So at this point, if we go into, let's say, router 4, router 4 should now have at least a couple of networks that are OSPF intra-area routes. He should have learned about the 232 network, and he should have learned about the 323 network as intra-area routes. So these 2 routes should show up just simply as O's in R4. And then R4 should also have learned about all these routes over here in area 1. And in R4's routing table, all of these will show up as OIA in the routing table. OIA standing for inter-area routes, routes that originated in some other area that router 4 is not connected to. Let's take a look at router 4. Show IP route. And there we have it. Here are the intra-area routes that are part of his own area. And OSPF as a metric uses cost. It uses cost, which is based on interface bandwidth. Just like the spanning tree protocol, the metric of OSPF is cost. It just uses a completely different formula. But the higher the bandwidth, the lower the cost. And here we see inter-area routes, learned from a different area. And those have a slightly higher cost because they're a little bit further away. And at this point, I think one other thing I want to show you, you can actually look at the database that contains your OSPF LSAs, show IP OSPF database, and it shows you your different LSAs. Now, at the CCNA level, like I said, you don't have to know about the specific kinds of LSAs. You don't have to know what their names and type numbers are. You don't even really need to be able to interpret the output of this command. I just wanted to show you that It is available to you, and once you get to the CCNP level and you start learning about the details of LSAs, then you'll start going into gory detail about the output of show IP OSPF database and some various keywords that you can add to it. But I just wanted you to walk away from this video knowing that you can go into the database and see various things. And other than that, we have gone through all of these show commands here. Oh, show IP OSPF interface. We haven't taken a look at that one yet. Show IP OSPF interface. And you can see it'll show you every interface that has been activated for OSPF because of a network command. It shows you the interface. It shows you what kind of network it is. Remember, we talked about that in a previous section. This is a broadcast interface. It shows you the OSPF cost. Remember, cost is based on bandwidth. If I went into the interface and I changed the bandwidth, that would affect the OSPF cost value. So OSPF's metric is much simpler than EIGRP. EIGRP used all sorts of factors to come up with a complex metric called distance. OSPF doesn't do that. OSPF just factors bandwidth and that's it, and it comes up with a cost value. It also shows you on a link who the designated router is, so you can see that. You can see this particular device, router 4, is the backup designated router, and you can see your interface priority. A lot of good information from the output of this command. And for troubleshooting OSPF, probably one of the best debugs is debug IP OSPF adjacency. That is a great debug to find out, why do I not have a neighbor? If I'm looking at a topology diagram and I say, well, router 1 and router 2 should be neighbors with each other, but when I do show IP OSPF neighbor, they're not seeing each other. Great debug to turn on. Debug IP OSPF adjacency will tell you what's going on and why they are not neighbors. Debug IP packets, I would recommend that you not use that debug. That debug can be very verbose, give you gobs of output in just a couple of seconds. Probably not a good idea to turn that one on.